Welcome to another video by Team Matcom. In this particular video, we will be discussing all the equations that is associated with the chapter 2, class 11 chemistry, that is structure of atom. In the case of the structure of atom, there are different aspects are there associated with the wave theory, wave nature and particle nature of matter, wave nature and particle nature of waves. So all these things we need to discuss, and the photoelectric effect, different equations are there. In this particular video, we will be just seeing the equation that is associated with it with respect to which concept, how can you substitute it. It just like a giving a brief idea about what is exactly discussed in the chapter 2 of chemistry, structure of atoms. Okay, so the first and the fundamental aspect what we will be discussing in the chapter, that is the mass of the electron. So the mass of the electron is basically 9.1 into 10 raised to minus 31 kilogram. When you are considering the mass of neutron or proton, when you are considering the mass of neutron or proton, when you are considering the mass of neutron or proton, that is equal to 1.6 into 10 raised to minus 27 kilogram. That means the mass of electron is 9.1 into 10 raised to minus 31 kilogram. Mass of neutron or proton is 1.6 into 10 raised to minus 27 kilogram. That means neutron and protons are 10 raised to 4 times, almost 10 raised to 4 times heavier than that of the mass of the electron. That is why when you are considering the mass of an atom, we will be considering only the mass of the neutron as well as the proton. We will not be considering the mass of the electron. When you're considering the charge of an electron, that is equal to 1.6 into 10 raised to minus 19 coulomb. I'm just speaking about the magnitude. When we are considering about the charge, electron will be having a negative charge. So the charge of the proton will also be equal to 1.6 into 10 raised to minus 19 coulomb. Then there is a relationship that will be connecting velocity with the frequency and wavelength. That is, velocity of light or the velocity of air radiation is equal to frequency into wavelength. So when we are using it in any medium, when you're considering in any medium, the velocity can be used by v is equal to nu lambda. But if it is in the vacuum, the velocity of light is a constant that is given by c, that is 3 into 10 raised to 8 meter per second. So in the case of a vacuum as a medium, we can use c is equal to nu lambda. In any other medium, we can use v is equal to nu lambda. There is another aspect which is associated with the wave nature of particle, that is a wave number. Wave number nu bar is equal to 1 by lambda. According to Planck's quantization theory, the energy is a quantized thing. That is, energy E is equal to h nu. H is the Planck's constant, nu is the frequency of the radiation. That means energy will be absorbed or emitted as a packet of radiation, not as other than not even be absorbed or emitted as other than the factors of h nu. Okay, what is the value of Planck's constant? That is 6.626 into 10 raised to minus 34 joules second. Another important aspect that we will be discussing in this particular chapter is photoelectric effect. That means if an electromagnetic radiation striking on a metal surface, so by utilizing the energy of that particular incident radiation, electron will be getting ejected out. So by connecting all these things, we will be having an equation that is called a photoelectric equation. That is, phi is equal to phi naught plus Ke. Phi is the energy of the incident radiation. Phi naught is the work function of the metal surface. Ke is the kinetic energy. That means energy of the radiation will be converted to the or utilized as the work function of the metal surface as well as the kinetic energy of the ejected photoelectron. This particular equation can be replaced as h nu equal to h nu naught plus half mv square. Nu is the frequency of the incident radiation. Nu naught is the threshold frequency of the metal surface. Half mv square is the kinetic energy, where m is the mass of the particle and v is the velocity of the ejection. Since it is electron, m is the mass of the electron and v is the velocity of electron. If we have two energy surface, E1 and E2, energy difference between these two surfaces, if E2 greater than E1 mean delta E will be equal to E2 minus E1. According to Planck's theory, we know that energy will be absorbed or emitted as a packet of energy as a packet of h nu. That means E2 minus E1 will be equal to h nu. According to de Broglie relation, that is wavelength of matter wave, that is lambda is equal to h by mv. Mv is nothing but mass into velocity is nothing but momentum. So de Broglie wavelength can be written as h by p. This equation is associated with the Heisenberg uncertainty principle. In the case of microscopic particle, if delta x is the uncertainty in measuring the position. Delta P is the uncertainty in measuring the momentum, will be greater than or equal to h by 4 pi. Since momentum is equal to mass into velocity, since mass is a constant, there will not be any uncertainty in the measurement. Therefore, we can write it as delta x into m into delta v greater than or equal to h by 4 pi, where delta v is the uncertainty in the measurement of the velocity. Okay, so if assume that if the uncertainty or if uncertainty in measuring one particular quantity is maximum mean, the other wind will not be having any uncertainty in the measurement. So according to Bohr relationship, energy of a stationary orbit can be calculated as minus 2.18 into 10 raised to minus 18 z square by n square. N is the principal quantum number or the shell number. Z is the atomic number. Z is the atomic number. This will be giving you in joules. The radius of the stationary orbit can be calculated as 52.9 into 10 raised to minus 12 n square upon z. N is the shell number, z is the atomic number. That is, the unit will be in meter. If 10 raised to minus 12 is removed, the radius will be expressed in terms of picometer. The energy difference between two energy level, that is between two energy level N1 and N2, can be calculated as 2.18 into 10 raised to minus 18 into 1 by N1 square divided by 1 by N2 square. If you need the what I can say wave number, that can be expressed as 109677 into 1 by N1 square minus 1 by N2 square. This 109677 is called the Rydberg constant. Rydberg constant. The last aspect regarding this particular chapter is associated with the principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. When n is equal to 1, L can have values from 0 to n minus 1. So L will be having only value that is equal to 0. ML value associated with L, that is minus L to plus L including 0. Since L is equal to 0, ML will be equal to 0. MS will be always either plus half or minus half. Corresponding to oneness subshell, it can have maximum of 2 electrons. When it is n is equal to 2, L can be either 0 or L can be equal to 1. When L is equal to 0, the similar to that of L is equal to 0 in the first shell, we can have a 2 electron, but L is equal to 1 mean ML can be minus L 0 plus 1, MS can be plus or minus 1 by 2. That means there can be 6 electron. That means P subshell can have a 6 electron. In the same way, when N is equal to 3, L can be 0, 1 or 2. If L equal to 2 mean ML can be minus 1, minus 2, minus 1, 0, plus 1, plus 2. MS is equal to plus half and minus half. We can have a maximum of 10 electron. These many aspects needs to be discussed in the point of with respect to equations in the chapter structure of atom. Hope the video is useful. If you need any clarification, do let us know in the comment section. As a token of gratitude, please like to this particular video, share with your friends, subscribe to our channel. Keep watching, keep learning. Thanks for watching. Bye.